Hey everybody, it's Mr. Henderson again. I'm going to be bringing you our next lesson for today. And we're going to be sticking with Module 12, the Enlightenment. And we're going to be sticking with Lesson 1, the Scientific Revolution. And we are going to be going into Part B today to finish this lesson. So yesterday we started off with Part A, where we wanted to understand how the scientific revolution first got started. And we talked about how the Renaissance, this rebirth of curiosity, will lead to things like exploration and wanting to go and discover more, which out of necessity then to create new technologies to spread that new information that we've about our discoveries. And all of these things change the way and radically, drastically change the way in which we are going to view life. We begin asking questions again. For a long time, we hadn't. We did as we were told. We believed what we were told. But we begin questioning again, just being curious, not out of defiance or against authority, but really just out of curiosity. And from that, new ideas sprung forth. And this brings us to the scientific revolution, where now we're going to talk about really the changes in science. The way that we conduct science, the way that we then convey science out and spread this information. And we started with Nicholas Copernicus and his new theory of the heliocentric theory. And we talked about how that was really just one piece of the puzzle and it didn't look like much yet. But then we had the supporting actors coming through. We had men like Galileo coming in and offering support to these theories. We had men like Tycho Brahe and Johannes Kepler offering more evidence for these. Sorry about that. I don't know what that was. Offering more evidence for this theory of heliocentrism. And so the case is building and building and building that our views of the universe that we had held for a long time are wrong. And if that can be wrong, that huge, big thing can be wrong, what else can be wrong? And this inspires more questions, bigger questions. So these are going to be the shoulders on which we stand to continue the fight, to learn more and find truth in our universe and in our lives. And today we're going to move into some other guys, some other people who are going to lend a hand to bringing about the scientific revolution, which will usher us then into the Enlightenment. So today we want to understand the new scientific method and how it developed. We'll talk about that. We're going to analyze the contributions that people like Francis Bacon, Rene Descartes, and Isaac Newton and some other scientists made to the scientific revolution, and also how science led to the Enlightenment. And tomorrow, when we get into those Enlightenment thinkers, Mrs. Bodis will be bringing you that lesson. And we're going to see then how the scientific revolution, this new change of how we conduct science, can be applied then to life. And that's what the Enlightenment thinkers are going to be all about. So today we want to be able to answer what were the contributions of these philosophers, Francis Bacon and Rene Descartes. We'll take a pause to answer that. And then at the end of the lesson, we should be able to answer, how did Isaac Newton, use observations of nature, just things that happen naturally, to explain the movements of planets? During the Renaissance, that period of rebirth and curiosity, works of the Greek philosopher Plato are going to be rediscovered. There's a great book out there called The Swerve. I'm interested in how things got started, why things began, because then we can really understand maybe where they're going. And I wanted to understand the Enlightenment more and how it got started, what really sparked it. There's a great book out there called The Swerve, which tells the story about this book hunter in the 1400s, which, think about that, a book hunter. Books were so rare, which means things that are rare are expensive. They're worth something. So book hunting was a very dangerous at times because people didn't want to part with their books, but also a very lucrative business. And a book hunter would travel all across the continent, all through the countries. He'd climb the highest mountains and go into the deepest valleys and try and find these lost, books, these lost philosophies that people had stored away. Because really the only people, think about this, that could even read a book were the wealthy. The only people that could write a book are the wealthy. So where would books reside? Being rare. with wealthy people. So oftentimes this could be a very lucrative business because they were also the ones buying these books. So anyhow, this book hunter is going through these monasteries, because really, where did a lot of the books then go? Because what books did most people need? The Bible. So how did you create the Bible? Making books was expensive. Printing books was expensive. But what does any religion have? Followers. People that are willing to do work for the good of their belief. So in these monasteries, you have monks that are sitting there with these ancient texts, these old scrolls even, and they're filing away at them, filing away the old texts, because the way that books used to be made, one, what it was written on, it wouldn't absorb the ink as well as what our paper does today. And on top of that, the ink had a metallic element to it. So instead of seeping into the parchment, it would actually rest on top. So you were able to scrape that ink away after it dried. You could kind of chip it away and basically then have blank pages in a blank book. And then you can rewrite it by hand. And that's what these monks would do. They chip it away. Who knows how much brilliant things that we have lost, from the burning of the library at Alexandria to monasteries chipping away at these old texts and these old philosophies and these old discoveries that we may never know about and are now rediscovering on our own or through research. And that's what this was. These book hunters, they would go and they would try and save these ancient texts from being chipped away. And one ancient scholar, a man by the name of Lucretius, was discovered. He was a first century BC Roman philosopher, so just before like Julius Caesar. And he wrote a book, you wouldn't necessarily call it a book at the time, but for our purposes, he wrote a book called On the Nature of Things, which really talked about how human beings operate and how nature in and of itself works together. The stream that flows through the forest works with the trees, and the trees work with the birds, and the birds work with everything works together, and the stars work with the earth as the moon and the sun do. Everything works together. And rediscovering this really brings a new perspective. So, in fact, none of these individuals are really challenging the church. Instead, what they're doing is they're just taking on a new perspective. Their eyes have been opened to other possibilities, and they just want to know more. And that really sparks curiosity and asking questions and challenging authority. And I don't mean that in a defiant way, but in a curious way, wanting to know more and after the truth, seeking truth. And one of those men that is rediscovered is Plato, an ancient philosopher, which we've all heard of. Philosophers are people who are experts in the study of wisdom and knowledge. That's what they spend their time doing. They're not out there necessarily making money. They just want to not only know more, but they want others to know more. They want to teach more and give more. So they would think about life and all the nature around them and how it all worked together. And they came up with a lot of theories. And Plato was going to believe that mathematics could be used to discover nature's truths. Mathematics, it can all be proved mathematically. Now, at the time, you got to remember, his education, even at that time, was far less than what we have today at your age. So he's on to something. Again, another single piece to a puzzle. Keep this in mind. Mathematics to discover the truth of nature. And this is over 2,000 years ago. And basically what he said was something like this. We can use mathematics from the simple things, like, if I tell you to put your hand on a stove, you're going to tell me no. I mean, it's turned on, right? Because you know what's going to happen. And you don't even have to have seen this in a TV show or even seen it happen to somebody or even have it happen to you in the past. When you see something that is glowing red, and when you get closer to it, you can feel the heat. You don't slam your hand on there because you know what the end of the equation is. You don't need to experiment with that. Mathematics proves the way in which we operate. Not only we as people, but the entire universe. Now, two men are going to follow in Plato's footsteps because, again, this is a 2,000-year-old idea, but it was lost for 2,000 years, at least 1,000, during the Dark Ages. But now it's rediscovered, and two men are going to follow in his footsteps and develop what comes to be known as the scientific method. They believe that the answers should be revealed at the end of inquiries, not at the beginning, not just using common sense, not just using reasoning, but going beyond that. Solving an equation isn't common sense. It takes work sometimes, as does experimentation. But if I just sit here and think about something, I can go, well, most likely, I mean, if you think about it, and we can come up with so many conclusions before we even begin to ask the question. The first guy here is going to be Francis Bacon. Francis Bacon is going to be an English philosopher, statesman, writer, scientist, and orator. An orator is like a public speaker. He'd get hired to give speeches and read things and also talk about policy and the government and things like that. He's going to write many books urging scientists to experiment in order to come up to conclusions. Don't, as I just said before, use your common sense or just reasoning, but actually go out there and test your methods. Test. For instance, you can think to yourself, think about this. What happens when you leave meat out in the sun? It spoils, right? So common sense might tell you that you could just pack, meat in cold stuff. But how would you know if you don't experiment with something like that? So he's about experimentation. I'll give you an example. And this is why I think a lot of my students, if you're in my room, you see a lot of Bacon stuff. And I think this is why students over the years have always got me Bacon stuff that sticks with them for some reason. But when I was about in 7th grade, I went to a buddy's house and he was making lunch and he said, "Hey, do you want some lunch?" I said, "Sure." And he said, "Okay, you want a peanut butter and bacon sandwich?" And I think you can probably guess my reaction. It sounds gross. It sounds disgusting. I'm like, "Oh God, no. What? Not a chance." He said, "Listen, you just got to try it." And I did. It was a fantastic sandwich. And when I didn't even think about this until I started teaching and we're talking about Francis Bacon. He's all about experimentation. And this just kind of popped into my mind. And ever since then, I've always experimented with bacon. I put bacon on everything. It's on my burgers. I have it for breakfast. It's in my salads. Everything. I love bacon. And I encourage you, experiment with bacon. Go home and try this sandwich, this peanut butter and bacon sandwich, which I know many of you, I think, will have this face. But personally, I think it's this. So go home and try it. Give it a shot. Let me know what you think. It's not for everybody, but it is very good. But anyways, the point here is experiment with bacon. And so make that connection. What is Francis Bacon all about? He's all about experimentation. And for this reason, Francis Bacon is considered the creator of empiricism. Empiricism is this idea, or this practice anyways, of basing your ideas and theories on testing and experience. Experiment. You gotta prove it, right? So for Francis Bacon, empiricism is experimentation. Experiment with bacon. But on top of that, it's ironic then that Francis Bacon, unfortunately, very sadly, he's a brilliant mind, and he's going to have a very unfortunate end, much like our guy Tycho Brahe. And as we talked about, experimentation is everything, and he believed that wholeheartedly. At the young age of 65, back in the 1500s, joking that's very old, and he wasn't in fantastic health to begin with, Francis Bacon is traveling in his carriage out to the countryside on a snowy day just outside of London. And all of a sudden in his carriage, he has an epiphany. The light bulb goes off in his head. He's enlightened, to say, to kind of use our words that we've been talking about. And the light bulb goes off and he says, "Hey, driver, stop here." And he stops at this poor woman's farm. And he goes to her and he says, I need to buy some fowl. He buys a chicken for our purposes. He buys a chicken and he begins stuffing this thing. It's a dead chicken. And he begins stuffing this thing with snow. Stuffing it with snow, because he's wondering, I believe if I think about it, using common sense, the heat will kill the meat and it spoil it, but the cold will preserve it. But how will I know? So let me get a chicken. I'm going to stuff it with snow. I'm going to stuff it with this cold snow, and then I'm going to take it and I'm going to put it, when I get to the mansion, I'm going to put it there and we're going to keep it cold. And we'll see if the meat preserves and it holds. The experiment worked. He proved, not just through common sense, but by experimentation, that you preserve meat using things like ice. That's why we put things in the freezer to this day. but it came at a high price. He didn't mean to die for his beliefs, but unfortunately, Francis Bacon, in his epiphany having moment, in his excitement for this experiment, he stayed out in the snow for too long. And when he got to the mansion, he was put into a bed that also happened to be a bit damp. And a couple days later, Francis Bacon is going to die from pneumonia. He died for his experimentation. He was a martyr for his cause. Not because he was willing to die for it, but because of what he did, we know a lot more. And because of that spirit, because of his ideas, we're going to continue on with the scientific revolution. And that brings us then to René Descartes, the other pair in this match. René Descartes is a French mathematician, philosopher, and writer. While Bacon was an observer and experimenter, René Descartes believed that you can just figure things out by reasoning. Going back to our Plato conversation, discovering Earth's truth and nature's truths and Earth's truths by mathematics, by reasoning, by creating an equation. So to boil this down to something very simple, Bacon, if we were to play the game Frogger, if you ever have done this, can you get to the other side of the road without getting run over? So you got to take your frog and you hop it over, one space at a time. Can you make it? Well, you look at, just by mathematics, you think about how many cars are going down, how much time there is, all the speed of the cars. Now, Francis Bacon would say, I wonder what will happen. Let me figure this out. I got to try this, and then I'll know. But at what expense? Meanwhile, the René Descartes of the world are saying, I'm pretty sure I can figure this one out for myself. Go ahead, Bacon. Hop at it. So much like Plato, René Descartes is going to come with the force of mathematics. We don't need to experiment everything. We can reason our way through things. In fact, he even proves, in his mind anyways, our existence through the application of mathematics. If you ever take a philosophy class when you go to college, you'll learn about this. He says, one of the biggest questions we have, are we even here? Why do we exist? Do we exist? Why do we? And in order to even get to the point of do we exist, we have to doubt our existence, right? Do you think the player, the character in a video game is sitting there on his off days going, why am I here? Do I really exist in this machine? No. We're always thinking, we're always doubting, and that fact tells us that we think. And the fact that we even think tells us that we exist. This means I doubt, therefore I think, therefore I am. So even the big questions, from something small like Frogger to the big questions that we all have of do we even exist, can be proved through mathematics. But I hope that I've shown you the pitfalls of both of these on their own. And that's what the scientific method is going to do for us. The scientific method is going to combine these two ideologies, the observational and experimental methods, along with the reasoning and mathematical methods. Both of these are needed in order to confirm our findings and to prove or disprove a hypothesis, and understand the language there. Every single one of us, and if you haven't, you will, have failed at a hypothesis or felt like we failed at a hypothesis. When you guys experiment with anything and you create a hypothesis, do not marry yourself to that hypothesis, because it's either way you're discovering truth, and that's what you should be after, not being right or wrong. When you disprove your hypothesis, it doesn't mean your hypothesis is wrong. It means you've learned what it's not. So always pursue the truth. And in order to do that, we need to combine all of these methods. First, we come up with our inquiry. Question first. And then we go and make observations. And then through our observations, we create what is, colloquially known as an educated guess, this hypothesis based on previous knowledge. But then we go and we actually experiment with that. We carry it out. And then we see through our mathematics in the hypothesis stage, did that work out? We collect that data, and then we crunch those numbers and use that data and that mathematical equation that we are going to find through this to not only make sense of the data that we have collected and write a conclusion, but also then to predict what is going to come up in the future. And we spread that knowledge around and we share that so that others can learn from us. From here, we're going to see an opportunity for us to pause and review our notes and answer the following questions. What were the contributions then of the philosophers Bacon and Descartes? And how did Bacon and Descartes each approach the scientific method differently? Go ahead and pause the video and restart when you're done. All right, welcome back. So we're going to move on with the scientific revolution here, and we're going to wrap up with Isaac Newton. Okay, so let's ask a quick question. Which of these falls faster, a pound of bricks or a pound of feathers? I know what many of us are thinking. We're thinking this. That bricks are obviously going to fall faster. They're bricks. The feathers are so light. But then there's a few of you at home that are watching this and you're going, no. You said a pound of bricks and a pound of feathers. The same. Even though a feather is lighter than a brick, it's a whole pound of feathers and a whole pound of bricks. So they fall at the same rate. Okay, next question. Based on what we just said, based on our previous data that we have collected, what's your next hypothesis? Which of these will fall faster? We said that because the feathers weighed the same as the bricks, that they would fall at the same rate. But if the feathers were just naturally lighter on their own, the brick would fall faster. So now many of us are still thinking that this is the outcome. But meanwhile, there are others of us that have seen through this whole charade and know this to be true. The golf ball and the bowling ball, despite being more dense and having greater mass, is going to fall at the same rate as that tiny little guy with dimples. Because gravity pulls on everything the same. And we're going to learn more about this, or a little bit more about this, but this is going to be revealed to us through a great scientist, mathematician, who's famously going to say, if I have seen further, it is because I have stood on the shoulders of giants. And the giants that this man is standing on, the shoulders he is using to see further and know more and gather greater data about the operations of the universe, are the men that we've talked about. Copernicus with the first piece of the puzzle, and then Brahe and Kepler with their elliptical orbits, and then Galileo adding to the credence by studying the movements of the planets. If not for these men, and many others, Isaac Newton would have no shoulders to stand on at all. But that's not to say he wasn't brilliant in his own right, because this man is going to go on to create, understand that, create physics and calculus in an effort to understand the secrets of the universe. All of this started because of one question. Is the Earth really in the middle? Are you sure? And here we are now. So we all know the story. Isaac Newton is this English scientist and mathematician. And one day he's sitting under an apple tree and an apple falls and hits him on the head. And boom, gravity. Well, it's not far off. The truth is, Isaac Newton was home from university at the age of 26, walking through his family farm out in an apple orchard. And while just pondering life, he did literally see an apple fall. And he questioned it. Why did that all of a sudden just make me, I've seen it all my life. And we know that this actually did happen because Isaac Newton wrote a letter to a friend that described this scenario, where he wrote in the letter a question to his friend. Why can't the apple fall sideways? Or upwards? That'd be silly. He didn't actually write that in the letter. But we know what he was probably thinking. That's crazy. How can that be? No, those things are, well, it's not so much why don't they fall up or sideways, but why do they fall down? What is going on there? Because of this question, and gets far more complicated than we have time for here today, but these questions lead Isaac Newton to create his law of universal gravitation. He's going to publish one of the most famous books ever, Principia Mathematica, which goes on to explain that the entire universe is operated by the same force, Universal gravitation, not just gravity here on Earth, but universal gravitation. And everything works in unison. It may seem chaotic, but if you could get far enough away, it's all mathematics. Where did this theory begin? 2,000 years ago in Rome, to a guy whose theories and ideas were lost and almost lost forever in a monastery that got found by chance. And because of this, we get to Isaac Newton, who's able to explain what before was the unexplainable. Why don't, when we jump, we just fly off? How do the planets move? And it's not just about gravity of the celestial spheres. His law of universal gravitation goes to the point that everything has gravity. Anything that has mass has power, has a force, and it pulls other things. From the smallest neurons in our minds that are floating around and bouncing and firing off synapses that are causing us to think and do things, to giant stars in the sky exploding. Everything is ruled by the same force. And obviously then this is far more watered down, and you're going to learn much more about physics and how the universe works and all this stuff as you go on. But this is the basic tenet of it. And the big question then that we should have for us in our content is then, how does Newton maintain the good faith of the Catholic Church? How does he maintain, because we're on the social level, we're studying human things. Science you'll learn. So how does he maintain the good faith? Because we know that the Catholic Church does not do well with people saying things that go against their teachings, especially at this time during the period of the Inquisition. Well, in that book, Principia Mathematica, he describes the entire universe like a giant clock. Everything works together, from the smallest little hour hand to the giant longer minute hand and the little pinion here and the power wheel there. Everything works together in unison. It's a giant clock, the universe. It's a mechanism. Let that sink in. It's a mechanism. So as far as the science can take us in the mathematics, Isaac Newton runs into an obstacle. He runs into a wall and says it just gets to a point where this was created. This has intelligence behind it. And he describes the universe like a giant clock, that all these parts work together and can be explained through these mathematics. If he just had the time, if he just had the tools, he could prove it all. So still, at the time, a lot of Isaac Newton's theories were just that, theories. But this is how he toes the line with the church. He says there has to be, imagine this, I take apart my iPhone and I take apart every little tiny piece to its bare bones, and I put all those pieces in a box, 1,000 of them, and I shake them around and I toss them in the air. How many times would I have to toss them in the air for them to land in the box just by chance as a completed iPhone? Would that ever happen? By chance? And the iPhone's pretty complex, right? There's a lot of pieces. So you're like, yeah, obviously. But what's more complex? The universe or your iPhone? To take all these things, these molecules and particles and every piece of matter that exists in the universe, and piece it apart, put it in a box and toss it in the air, how many times would it have to come down and fall out this perfect universe that allowed our life to flourish? What are the chances? So Isaac Newton is able to keep the faith of the church by saying that there is a clock maker, that God is the unseen clock maker of the universe. Now, this view of the relationship between God and the universe is called deism. And this is something that a lot of people took on during this time, because you got to remember that the Catholic Church politely could be oppressive. There was no dissension, and if there was, you were killed, you were burned at the stake, you were beheaded, you were drowned as a witch, you were whatever. So a lot of the scientists, it was very hard for them, of this empiricism, experimentation, to see it, to believe it kind of people. It was hard for them to really believe that a man in a cave could rise from the dead and float off to heaven and be the Son of God. It was hard for them to accept those supernatural miracles that many believers put faith in. And that's not to say one is right or one is wrong. What I'm saying is, for these individuals that were based in science, it was hard for them to accept that supernatural. And this was a way for them to acknowledge that there had to be a two-part system: science and then a greater intelligence, whether that is a Christian God or a Muslim God or a Buddhist God or whatever a God. All we know is there is something greater, a creator, the great creator. Now, this is a way for them to hide then, and you could say that to really any religion, because they go, oh yeah, they're talking about our God. So naturally the Catholic Church looked and goes, oh, okay, good. You're not competing with us. You're saying there is God and he created everything. Okay, we're good then. But it wasn't exactly that. So anyways, I'm going to stop here in the essence of time. And I think that you guys have one little section that you're going to finish on your own, and that is the spread of the scientific revolution. The scientific revolution spreads. We're going to talk about some medical stuff. A man named Galen, who was an ancient guy, and then Vesalius, who's going to correct a lot of those ancient ideas in the human body. Medicine, you're going to learn. You're going to learn about the discovery of the very first vaccine for smallpox by a guy by the name of Edward Jenner. And also then you'll learn a little bit about Boyle's law, the great chemist Robert Boyle. All right, so, and there's not much there. It's just a couple paragraphs. You're going to finish that up and then go ahead and complete your worksheet. And that is it for section 1. Be ready for a quiz. If you have any questions, email your teacher or myself. Bye.